Hello friends, I welcome you to my YouTube channel MacPM. So in today's video we will solve a numerical problem which is based in torsion in combined shaft. So here we will see that these two shafts are in series and we have to find the torque in these two shafts. So let's see the problem. A vertical compound shaft is made by securely fixing a 500 mm long brass bar to a 500 mm long aluminium bar. So one is brass, one is aluminium, and these two have same length 500 mm. The diameter of each bar is 40 mm, so they have same diameter. So L1 is equal to L2 is equal to 500 mm and D1 is equal to D2 is equal to 40 mm. The aluminium bar is rigidly fixed at its upper end, so it is fixed here at this point, and determine the maximum torque which can be applied at the lower end of the shaft. So here we are applying some twisting torque. So what is the value of maximum torque which can be safely transmitted by this shaft? So we have to find that, and which can be applied at the lower end of the shaft if the maximum angle of twist is not to exceed 3 degree. So theta max is equal to 3 degree, and the maximum shear stress in the aluminium and brass is tau max is equal to, in aluminium is 78 megapascal or Newton per mm square, and tau brass is 55 megapascal or Newton per mm square. G brass modulus of rigidity of brass is 34 into 10 to the power 3. If we convert it into Newton per mm square, then 34 into 10 to the power 3 Newton per mm square, and Ga aluminium is 28 into 10 to the power 3 Newton per mm square. If you are wondering how we are converting gigapascal to Newton per mm square, then gigapascal is equal to 10 to the power 9 pascal, which is equal to 10 to the power 9 Newton per meter square. If we convert meter into mm, then 10 to the power 9 into 1 by 1000 meter will be mm now, because 1 meter is equal to 1000 mm to the square, so it will become 10 to the power 3. So 1 gigapascal is equal to 10 to the power 3 Newton per mm square. Okay, so we have to find maximum torque. Now if we calculate polar moment of inertia, so Ja, both the shafts have same diameter, so Ja is equal to Jp is equal to pi by 32 d to the power 4 is equal to pi by 32 40 to the power 4. If you will calculate it, then you will get 80,000 pi mm to the power 4. Now we know that from torsional equation T by J is equal to tau by R is equal to J theta by L. So if we consider this portion, then T by J is equal to tau by R, or torque is equal to tau J by R. So we are trying to find maximum torque, so we will put maximum stress here. Okay, so for aluminium, first of all we will calculate for aluminium. So suppose it is Ta is equal to tau aluminium. What was tau aluminium? Shear stress in aluminium was yes 78 into J. What is J? 80,000 pi divided by R is d by 2, so 40 by 2 is equal to 20. So if you will calculate this, then you will get torque in aluminium is equal to 980,177 Newton mm. Okay, this is torque in aluminium. Now if you will calculate torque in brass, then you will get tau brass into J brass divided by R radius of brass. So tau is 55 Newton per mm square into J is 80,000 pi for both because they have same section, and D is also same, so D by 2 is 20. If you will calculate this, then you will get 691,150 Newton meter. So there are two stresses. This aluminium can take stress up to 980,177, and this brass can take stress up to torque up to torque up to 691,150 Newton Newton mm, which means if we apply more than this torque, then this brass bar will break under shear stress. So this stress cannot be applied. This stress can be applied up to here in aluminium, but brass bar will fail before this at this point. But if we apply this stress, then brass bar will not break, and aluminium also safe because it can take up to 980,117 Newton meter. So in these two, if we have to select, we will select lower value 691,150 Newton mm. So this is criteria regarding to shear stress, but we have been given one more condition: maximum twist is not to exceed 3 degrees. So these bars are in the series, so theta is equal to theta 1 plus theta 2. Angle of twist will be added because these two are in the series, or theta aluminium plus theta brass. Okay, now from our equation, T by J is equal to G theta by L. T by J is equal to G theta by L. So our theta is TL by J. So total theta is equal to theta aluminium plus theta brass, TA LA upon GA JA plus TB LB GB plus JB. Okay, now what torque now will be same in the boss shaft because we have selected this value. So torque is this, and this torque is for shear force. For this theta, we will find torque. What is the allowable torque, maximum torque which it can take? This is T. So torque will be same because the shaft in series, and theta will be added. So theta is added here. Theta is equal to theta 1 plus theta 2, but T1 is equal to T2. If these two shafts are in series, and if T is applied here at the one end, then it will be transmitted up to here. So torque T will be same throughout the shaft. Okay, so T is common here, T, and J is also same because these two have same cross section. So theta will become T by J LA upon GA plus LB upon GB. Now if you see L is also same, so if this L will come out, this will become 1 by GA 1 by GB. So this theta is given as 3 degree, but theta in the equation is in radian, so we will convert it into radian. So we will multiply by pi by 180. Okay, so this value 3 into pi by 180 is equal to T into L is 500 mm into J is 80,000 pi. We have calculated it here. 1 by GA, so GA is 28,000 plus 1 by GB is 34,000. It is given in the question, 28 and 34. Okay, so if you will calculate T from here, then you will get T is equal to 404,120 Newton mm. So we have two values now. This is 1T which we had accepted, and this is also a torque which we have accepted. So if we have to cause the maximum shear stress, then this much torque we can apply, this one. But if we have to restrict the angle of twist up to 3 degree only, then only this torque can be applied. If we apply more than this torque, if we apply this torque up to here, then angle of twist will be more than 3 degrees. So we cannot apply torque which is more than this. So we have to select the minimum value. So maximum torque which fulfill all the conditions will be equal to 404,120 Newton mm or 404.12 Newton meter. So this is the answer. I hope you understood this problem. If you have any doubt, then please ask in the comment section, and if you liked our video, then please subscribe and share to our channel. Thank you for watching.